Following on from the previous two videos, we got to a stage where when given a complicated function, we can always draw a tangent line right at any given point, let's say x0 here. And the way we do that is by looking at the given complicated function, differentiate it. That will then give us the gradient at this point here. And we will always know one particular point on that line. Because if you put x0 into this original function here, it will then give us the y right at this point here. So we will always know this point here, and the coordinates at this point will be given by this, comma, this. Okay, but the point here is that we can always draw the tangent line right at that point, and so the equation for this tangent line here is given by this. And this thing here is quite hard to remember, but it's a bit like me giving you this here. It's a bit like me saying I've got a straight line that has a gradient of 4 and it crosses through this particular point, and then asking you to come up with an equation for this straight line here. So looking at this problem here, I've given you the gradient, and I've given you a particular point. Looking back up here, I've given you a particular point here, x, comma, y here, and I've given you the gradient. So it's your job here to come up with the equation for this line here. So that's very similar to this here. So for you to come up with an equation for this line here, you would start off with y equals mx plus c. You know the gradient, so you would put it into here. So that would then give you this. But then you still need to know the c. So to find out the c, you need to know one particular point on that line, which is 2, 3. So this is your x, so you would put it into here, and this is your y, put it into here, and then blah 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 to work out c. So therefore, blah blah blah, c equals -5, giving you your equation here. So it's pretty much the same thing here. I've given you a complicated function, but the thing is, you can always find the gradient. You always know the one particular point, this, comma, this, and then you can always jump to, well, you can always draw the tangent line. You can always draw the tangent line here, and the equation of this tangent line here is given by this. Okay, so yes, we can say the equation for the tangent line here is given by this. We can say y equals blah blah. We can say that this here is our equation, but we're going to use this symbol here. We're going to use the linearization of f of x here. So yes, we can leave it as y equals blah 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 mx plus c, but it's better to use this. It's better to use this symbol here because the minute you use this symbol here, other people looking at your work will be able to see that, oh, you've deliberately went out of your way to create a straight line. You've manufactured a straight line here. So this symbol here, it communicates to other people that you deliberately went out of your way to create a linear line, and that linear line is this line here. So when you use this L bracket x close bracket here, people will know that you deliberately went out of your way to create a linear line. So you can say that, oh, your complicated function here is roughly the same as the straight line that you deliberately created near a particular point. Okay, so by you using this symbol here, you're able to communicate to other people that you deliberately went out to create a linear line, where you can say that, oh, my linear line here is roughly the same as this complicated function here, around this particular point here. So looking at the diagram here, so by you using this L bracket x here, you're able to communicate to other people that you deliberately went out to create an equation for this line here. Okay, for this line here, and then you can say that, oh, the line that I created is roughly the same as this complicated function here, roughly the same. So this is approximately this, near x equals 0, near x equals near x 0 here. So that means is that looking at this, our manufactured straight line here is roughly the same as the complicated function near this point here. So near this point here. So basically just around this region here. Okay, it's no longer valid around here or around here. Okay, but the important thing is that this is a linearization of f of x. Okay.